A histogram is a graph that displays the data by using contiguous vertical bars, unless the frequency of a class is 0, of various heights to represent the frequencies of the classes. Its purpose is to provide us with a graphical display of the distribution of a dataset. Here we have a grouped frequency distribution that represents the number of members of the 2016 United States Electoral College for the election of the president. So let's start with a blank piece of paper. Along the horizontal axis, we will put the boundaries, but our histogram needs to convey more meaning than just displaying the boundaries. The boundaries represent groupings of the number of electorates, and the histogram should be labeled according to the variable that is being studied. So we will evenly space the horizontal axis with the boundaries of the grouped frequency distribution. They are 2.5, 10.5, 18.5, 26.5, 34.5, 42.5, 50.5, and 58.5. The vertical axis will be labeled according to the frequencies of the grouped frequency distribution. We see that the frequencies go from 0 to 34, so we might select a scale from 0 to 40 and mark the vertical axis by 5s. It is important that the vertical axis starts at 0 so that we portray an accurate proportionality between the classes. The class that extends from 2.5 to 10.5 has a frequency of 34. So we will draw a vertical bar that spans the width of the first class with the height of 34. The second class has a frequency of 11. So we will draw an adjacent contiguous vertical bar that spans the width of the second class with the height of 11. The third class has a frequency of 2, so we will continue this process until the entire histogram is constructed. We can now get an impression of the distribution of the dataset at a quick glance. Note that the most frequent class is the first, which extends from 2.5 to 10.5. This particular distribution possesses what is referred to as a reverse J-shape.